Welcome to Basic Technology for JSS 3, second term. Today we study two important electronic components, capacitors and inductors. Recap: Basic electronic components. You have already studied resistors, which resist the flow of electric current, and diodes and transistors in earlier classes. Today we focus on capacitors and inductors, two components that store energy. Capacitors. A capacitor is an electronic component that stores electric charge, and therefore electrical energy, and releases it when needed. A capacitor consists of two conducting plates, electrodes, separated by an insulating material called the dielectric. When a voltage is applied across the capacitor, electric charge builds up on the plates. One plate becomes positively charged, the other negatively charged. This creates an electric field in the dielectric. Capacitance is the measure of a capacitor's ability to store charge. Symbol for capacitance, C, SI unit, farad, F. In practice, farads are very large. We commonly use microfarads, μF equals 10 F, and picofarads, PF equals 10 superscript 1 superscript 2 F. Formula, C equals Q/V, capacitance equals charge/voltage. Symbol. The circuit symbol for a capacitor is two parallel lines, representing the two plates. Types of capacitors. 1. Electrolytic capacitors, large capacitance values, μF. Have a positive and negative terminal, polarized, must be connected the right way round. Cylindrical shape. Used in power supply circuits. 2. Ceramic capacitors, small capacitance values, PF to NF. Not polarized, can be connected either way. Disc or chip shape. Used in high-frequency circuits. 3. Film capacitors, reliable and stable. Used in audio circuits. 4. Variable capacitors, capacitance can be adjusted. Used in radio tuning. How capacitors work in circuits. Charging: when connected to a battery, the capacitor charges up, stores energy. Discharging: when the battery is disconnected, the capacitor releases its stored energy. Blocking DC: a capacitor blocks direct current, DC, from flowing through it once fully charged. Passing AC: a capacitor allows alternating current, AC, to pass through it. Because the voltage is always changing, the capacitor continuously charges and discharges. Applications of capacitors. Smoothing in power supplies, reduces ripple in DC output. Timing circuits: capacitors charge and discharge at predictable rates. Filtering: separating different frequencies in audio and radio circuits. Motor starting: capacitors provide phase shift in AC motors. Camera flash: large capacitor stores energy and releases it rapidly as a flash. Inductors. An inductor, also called a coil or choke, is an electronic component that stores energy in a magnetic field when electric current flows through it. An inductor is simply a coil of wire. When current flows through the wire, a magnetic field is created around the coil. The measure of an inductor's ability to store magnetic energy is called inductance. Symbol for inductance, L, SI unit, Henry, Vich. In practice, we often use millihenries, mH equals 10 superscript 3H, and microhenries, μH equals 10H. Key property of inductors: electromagnetic induction. An inductor opposes changes in current flowing through it. When current increases, the inductor produces a voltage that opposes the increase. It stores energy in the magnetic field. When current decreases, the inductor releases the stored energy back into the circuit, trying to maintain the current. Applications of inductors. Filtering: inductors block high-frequency AC while allowing DC or low-frequency AC through, used in power supplies. Transformers: two coupled inductors transform AC voltages. Radio tuning: inductors and capacitors together form resonant circuits that select specific radio frequencies. Electric motors and generators. Chokes in lighting circuits, fluorescent lamps. Comparison. Capacitor, stores energy in an electric field between its plates, blocks DC, allows AC, unit equals farad. Inductor, stores energy in a magnetic field around its coil, allows DC, blocks high-frequency AC, unit equals Henry. Remember, capacitor equals electronic component that stores electric charge and electrical energy, plus releases when needed, consists of two conducting plates, electrodes, separated by insulating material called dielectric. Charge builds up on plate's electric field in dielectric. Capacitance equals measure of ability to store charge, symbol equals C, SI unit equals farad, F in practice equals microfarads, μF equals 10F, plus picofarads, PF equals 10 superscript 1 superscript 2F formula, C equals Q/V, capacitance equals charge/voltage. Types, ELECTROLYTIC, large capacitance μF, polarized equals has positive plus negative terminal equals must be connected right way round, cylindrical, power supply circuits, ceramic, small capacitance PF to NF, not polarized equals can connect either way, disc or chip shape, high frequency circuits, film, reliable plus stable, audio circuits, variable, capacitance can be adjusted, radio tuning. How capacitors work, charging, connected to battery, capacitor charges up equals stores energy, discharging, battery disconnected, capacitor releases stored energy, blocks DC, direct current once fully charged, passes AC, allowing because voltage always changing, continuously charges plus discharges. Applications, smoothing in power supplies plus timing circuits plus filtering, separating different frequencies. Plus motor starting plus camera flash, stores energy plus releases rapidly. Inductor/coil/choke equals electronic component that stores energy in magnetic field when electric current flows through it, simply a coil of wire, current through wire equals magnetic field created around coil, inductance equals measure of ability to store magnetic energy, symbol equals L, SI unit equals Henry, H in practice equals millihenries, dmH, plus microhenries, μH. Key property, inductor opposes changes in current, current increases inductor opposes the increase, stores energy in magnetic field, current decreases inductor releases stored energy, tries to maintain current. Applications, filtering, blocks high-frequency AC, allows DC or low-frequency AC through equals power supplies. Plus transformers, two coupled inductors transform AC voltages. Plus radio tuning, inductors plus capacitors equals resonant circuits, select specific radio frequencies. Plus electric motors plus generators plus chokes in lighting, fluorescent lamps. Comparison, capacitor equals stores energy in electric field between plates, blocks DC plus allows AC, unit equals farad, inductor equals stores energy in magnetic field around coil, allows DC plus blocks high frequency AC, unit equals Henry. Thank you for studying basic technology with us today.